Howdy. Welcome. I'm Jeffrey Snover, late technical fellow. I was in the other hallway. I was convinced this was at 1 o'clock, and I was in the middle eating a sandwich when I get this text. It just gives a room number. It's like, well, that's interesting. And then I looked. So, panicky. I'm joined with?
Hi, I'm Filippo Seracini. I'm one of the program managers in the Azure Stack team, and my area of focus is everything related to security and compliance in Azure Stack.
Great. So if you're not up on the current state of security, oh, let's see. How do you do that?
Let's figure it out.
Yeah, it's right there. Click, click. Oh,
there you go.
Hey, maybe you haven't been keeping up on current events, but we just got our asses kicked, pal.
Okay, so that's my summation of the state of cybersecurity. Great. So, if you're not keeping up to date, things are bad, right? So you had massive breaches, an Anthem, zero-day attacks, 117 million passwords linked or email accounts linked, Instagram, millions of records hits. You probably heard of the latest ones, Petya and WannaCry, and then our friends in the credit industry having to send out 143 million letters of apology. It's a mess.
Yeah, and when I was preparing that slide, actually, after a while I stopped because I was feeling bad of so many bad news and so many millions and millions of accounts. So I said, okay, those are enough. But it took me really maybe 2 minutes to make this slide and find all this unpleasant news.
Yeah, exactly. I said, hey, just find a slide with some headlines. Turned out that was a pretty easy task to do. And you don't have to go back very far to fill up that slide. So, if we're just honest with ourselves, the state of security is not very good. And for quite some time, I had been a security pessimist, right? And really, it was part of Windows Server planning. We break down Windows Server planning into 3 areas. There's voice of the business. These people look at the market trends, what people are paying for, where the startups are, et cetera. Then we had voice of the customer, and these are people listening to customers, finding out where their pain points are, what their hopes, dreams, and ambitions are. And then there was state of the voice of technology, and I owned the voice of technology planning for Windows Server. And at the time, I looked out there and had come to the conclusion that the bad guys were getting better, faster than we were at defending. And it turned out around that time, this guy, Edward Snowden, released his stuff. Now, like or hate Edward Snowden, the reality is this. This guy had a fundamental impact on the security industry and a beneficial impact on the security industry. And why? And the answer is, I would have security researchers come to me and they would say, hey, Jeffrey, we have to protect against this. You have to have a big investment to protect against this sort of an attack. And they'd explain some wild, crazy, esoteric thing. And I would hear this and I'd say, well, okay, we could do that, but perhaps we could have a more cost-effective thing by buying you another layer of tin foil for your hat, okay? And what happened was that, I just love the expression on that cat. That cat is just the most precious thing in the world. But with Snowden, what we realized that these were not hypothetical. These guys are walking in for the first time like, what did I get myself into? What we realized with Snowden was that these were not esoteric, hypothetical attacks. These were real attacks being exploited in the wild. Now, many people will then say, hey, Jeffrey, stop. That is the legitimate, righteous espionage of a nation state. And I've got a great point, but I don't care. The reality is this. The reality is that they are exploiting vulnerabilities in our systems, and I found out that it could really be done versus hypothetically be done. And those vulnerabilities are available to them, are also available to the bad guys, And if it's available to the bad guys, the criminals, then it's also going to be available to the script kiddies. It's just a matter of timing. And indeed, I assert that this observation made a number of years ago proved correct, proved exactly spot on with WannaCry and Petya. Here, the attack toolkit of a nation state, the NSA, it's reported, was stolen and then weaponized by script kiddies and used to attack a wide group of people. So exactly that threat. So we needed to address this. And it turned out that a number of people throughout the company were having the same conclusion at the same time, or reaching the same conclusion at the same time. Now, Michael Hayden was out at this time saying the following: hey, wake up, guys. You know, you are in the fight. Whether you accept it or not, you know, you were in the fight whether you thought about it or not. Number two, you were almost certainly penetrated. Okay, so pretty scary stuff. So, we're going to talk about the...
And Jeff, if you don't mind,
please, please.
One point I would like to raise the attention on is that what Michael Hayden said does not apply only to big banks or huge insurance company. It applies to any size of companies. And the WannaCry actually was very evident, because the script that was created by some nation-state attackers actually, as Jeffrey just said, went in the hands of regular criminals. They start attacking anywhere they could possibly reach. So instead of, maybe it was designed to attack a specific Department of Defense or something like that, but end up in attacking any kind of size of any kind of industry worldwide. So don't think of, if you're not in a super large industry or your company doesn't make billions and billions of dollars off the risk. Actually not. There is no really difference in what business you are in. You are a target.
Yeah, that's a very great point. There are lots of different, you know, there is a portfolio of bad actors out there. They have different targets, they have different methods. Some of them are after state secrets, some of them are after technology secrets for nation state gain, some of them are after commercial technologies or business intelligence for commercial espionage, and some of these people who are just, if you have anything of value, if I encrypt it, you'll pay me money to give me something to get it back. So, does anybody not have anything of value? Good, I'm glad to hear that. You are all targets, right? You are all targets. And again, targets not just from script kiddies, targets from script kiddies who are using the toolkits of nation states. Okay, let that sink in. Script kiddies targeting you because they're encrypt your stuff and to get a couple $100, but using the toolkits of nation states. Okay, so here's the challenge. The evolution of evolution is evolving. Yesterday, evolution was this. Okay, it said a general purpose building blocks, right? Whether it's the network, the hardware, the operating system, the middleware, the framework, the applications. As a supplier, my job was to give you the best of one of these things and the capability for you to lock it down and secure it. Then that gets applied to a set of custom processes. Each company, each department, each project will take these general purpose capabilities and they'll apply their own management, their own policy of if and when to update things, in case you're not up to date. Recently, a company had to send out 143 million apology letters and take a huge business impact because a well-known vulnerability in PHP struts, it's PHP struts, wasn't it? PHP struts, that they had a patch for early in the year, a decision was made to not take that patch. Bam, got whacked. And security. How do you secure these things? And it turns out securing these things is very complicated. And I will just assert that this process of we give, suppliers produce general purpose components, give them to everyone, and then everyone has to figure out how to manage, update it, and secure it, is not working well as an industry, okay? Because what happens is this leads to lots of opinions. I guarantee you at that company there was somebody saying, boy, it is important that we patch struts ASAP. And there was somebody else who said, well, I don't think so. And that person won the day, and that difference of opinions was not a good one, right? That didn't work out well. There's often duplications. There's lots of inefficiencies, and there's lots of security risks. Okay, the reality is when you have lots of moving parts, comprehensively understanding those things as components in and of themselves, and then as systems, is extraordinarily difficult, and often being done by the people who are just trying to put them together and get them to work in any way, shape, or form anyway. I mean, look, the reality is that's hard enough. Just like, okay, hey, you gave me all these parts, and they're supposed to do this, but where's that easy button, right? And the answer is, rarely is there that easy button. So a lot of people have to do their own systems integration to put all these parts together, and they are spending all their time and effort just getting it running, and the reality is, often they don't do the job to actually secure it. So that's evolving, okay? It's evolving. Now we have cloud infrastructure, we have IaaS, we have PaaS, we have SaaS applications. Now you combine that with pre-validated and predefined and validated processes, right, for management, security, and updates. And now what we're doing is we're on the edge of a much better world, right? It's a different world, but it's a much better world, a much more secure world, right? A world of hardened infrastructure, a world where we have well-defined interfaces and roles between the hardware and the software, well-defined interactions, and very well-defined administration. Now this all sounds pretty good, but let me give you an example. I've been very, very impressed with the Azure guys, right? They're doing a great job. And so I thought to myself, well, how is that possible? You know, what's really going on here? And what I realized was we had a phenomenon like this, right? And the answer is, sometimes you're better off just hiring a specialist, okay? Like, I'm sure that guy thought, hey, how hard can this be? I'll just secure my own backyard. And again, not too well. So this is really sort of the change in security is kind of moving from one model to the other. And I used Minuteman here, and I thought, well, that's actually not quite it. It's really, if you think about it, the way we have security today, it's more like the wild, wild west, right? The wild, wild west, where you are yourself, you know, your family lives on a big ranch, and when you want to secure it, you get yourself a rocking chair, a blanket, and a rifle, and you sit on the porch all night, right? And then, by the way, then you got your day job doing ranching, okay? That's a pretty tough world, and the reality was, only protected you against a pretty narrow band of effects. But then what happened? What happened was towns grew up, and when towns got to a sufficient size, you could hire a sheriff. And when they got to a better size, you could hire a police force. And when you got sufficient sizes, all of a sudden you would have a nation, and you would get yourself an army, first on-demand armies, and then standing armies. And when you have standing armies, you have specialization, and all of a sudden you got guys like this who train every single day, the world's best soldiers, the Navy SEALs, and how many of us are sitting on their porch with a rifle? Okay, maybe some of you guys, you're pretty dodgy, but no, most of us have our security taken care of by someone else, and in reality, we're pretty secure. So now, this is a kind of composition diagram of sort of microservices of a particular set of Azure things. And here the details don't really matter. The key thing I want to point out is that each one of these components is a microservice in and of itself. These are components that are interacting with one another through protocols. And the interesting thing about that is that because things interact through protocols, it allows individual teams, so kind of here's the gestalt of microservices. Gestalt of microservices is, if we can agree upon a protocol, and you can do whatever you want to do, and I can do whatever I want to do, as long as we keep the contract, okay? So concretely, you can go from 1 machine to 2 to 2,000 to 2 million. You can go from Linux to Windows or Windows to Linux. You can go from version 1 to version 2. You can go from C++ to C# to Erlang to Earwax to Nosehair. You can do anything you want as long as you implement the protocol. And so can I, okay? The heart of microservices. Here's the other heart of microservices. Now you're responsible for maintaining that thing and securing it. So guess what? You don't have to secure a general purpose thing. You know exactly what you have and you can secure it. So what this translates to is each one of these teams sort of has this group of Navy SEALs defending that microservice. They know exactly what should run. This is not a general purpose system. This is a system that has exactly one job, to run Hadoop or the VM rule or whatever, runs Hadoop. They know exactly the software. The only software that should be running on it is their software. They know who should be talking to it via what protocols, and they're able to lock that down. And then they're able to have red teams go penetrate and try and attack them and up their game. Azure is hiring the world's best security people, and we practice and we practice and we practice, and we up our game constantly, and we harden these services. So in this world, what I'm kind of really getting to is, as we move away from general purpose things that can do anything to more special purpose things, or really I'd say large complex system built out of components where each component is extremely well defined and the interaction between the components is very well defined, we now have a context where experts can come in and really lock down and provide next generation security. And that's essentially what we're doing with Azure Stack, okay? Azure Stack enforces strict layering. It is an integrated system. It is not general purpose hardware. With Azure Stack, you don't bring out your favorite hardware vendor's catalog and say, oh, well, I love this one, I love that one, I'll put these together this way. No, you pick a vendor, you pick a capacity for a 12 nodes, this vendor. That's what you get, okay? We have worked with those people to integrate those systems. We then deploy it. You don't deploy it, we deploy it. We maintain it. It is a tightly layered system. Azure Stack is the only thing that talks to the hardware, and then the tenants talk to Azure Stack. So your workloads, you do anything you want. You use Erlang, you use Linux, you use Windows, you use Hadoop, you do anything you want in the tenant space, but they talk to the infrastructure. That infrastructure is a sealed infrastructure. You don't put your agents in that infrastructure. You don't put your agents in that hardware. It's sealed, and because it's sealed, it is tightly secure. So why did we take the stand? And the answer is motivated by the need to have Azure consistency, okay? As the lead architect for Windows Server, I had a lot of conversations along the lines of this. So first, let me motivate it. The goal of Azure Stack is to extend Azure to more customers and more scenarios. Concretely, to take a set of Azure services and run them in customers' data centers so that you can write applications and have a choice of where to run them, and to create an ecosystem. You write solutions for Azure, they should work everywhere across the planet. If wherever you are across the planet, if you're using Azure, you should be able to pick up a solution and use it anywhere, okay? That's the vision. Now, in order for that to work, we have to be consistent with Azure, and that's not a point-in-time statement. That's a transcendental relationship. It has to be true across multiple points of time. Now, as the lead architect for Windows Server, I'd have lots of conversations like this. Hey, I'd love to go to the latest version of the operating system. However, I use this third-party software, and that third-party software doesn't work on the new OS, so I'm gonna have to wait, okay? Or, hey, I got this new software, I got this third-party software, and it works on the new version of the OS. I said, okay, well, what's the problem? Oh, they wanna charge a full relicensing fee. So it makes no economic sense for me to move to the new version of the operating system. And more often than not, what we find is, hey, I'd love to move to the new OS, but I have this third-party piece of software, and they went out of business. I'm never gonna move to that new operating system. And that's why you have so many people on 2003. I see lots of heads like, oh yeah, I know what he's talking about. No, it happens a lot. So because it is a metaphysical requirement, it is an existential definition of Azure Stack that I am consistent with Azure, I can never allow anything to ever interrupt keeping up to date with Azure. And therefore, for the hardware and our infrastructure, there are no third-party components. There will never be any. Don't ask for any. I'm never going to allow them. If you have a real hard requirement for that, grab general purpose Windows, grab general purpose System Center. With those tools, you can do anything you want, but you won't get Azure services, okay? Because Azure services, it's all about being consistent. So the strict layering turns out, so we have this idea of the sealed host. The only thing that runs on it is the software we sign, and the only third-party software I sign is the drivers that I've worked with my integrated partners to validate, to jointly validate. In Azure Stack, boy, do I got a lot of parts. But the great thing of those parts is I know exactly what they are, I know exactly what should be running, and I know exactly who can talk to who via what protocol. And this freedom of having the sealed host gives us the freedom to change it any way I want, any time I want. I can say, hey, I'd like to move some of these things from a VM into a container. Hey, I'd like to take these two things that are on one VM and put them in two VMs, or two VMs and put them in one VM. And I can continually lock it down, finer and finer grains. Hey, let's update the ACLs. Let's change the firewall configurations, etc. The result of this is truly awesome security. So again, I had been a security pessimist, and now I'm a security optimist. Again, here is a block diagram. Actually, this is a simplified block diagram of the Azure internals. But internals are internal. We don't talk to people about the internals because they're going to change, and it's not the value proposition of Azure Stack. The value of Azure Stack is you able to buy infrastructure and focus on the things that differentiate you, applications.
Thank you. So actually, before we move to this slide, I want to spend one more second.
You want to talk to this slide.
On this one.
I stepped on your slide.
I know, this was mine.
Oh, I screwed up.
So one thing I want you to think about it. If you were the security architect, right, in your company, and this is the architecture you have to secure, think of all the accounts that you have to figure out how they work, who can talk to who, what network, what ports, what encryption, the certificate for the encryption, how you manage those certificates, how you manage the rotational, and the entire life cycle of the password of all those accounts, and so on and so forth. Who can talk to who, why, when, what is allowed, what should not be allowed. So all of these considerations, they will spend months and months. I bet that you won't be able to do in less than 6 months if you're really, really good. So all of that work, it's done for you in Azure Stack. You don't have to worry about those accounts. You don't have to worry about those certificates. You don't have to worry about the life cycle of those accounts and certificates. Those is done for you in Azure Stack. So one thing is we are very proud of in Azure Stack is really the security posture. We really invest a tremendous amount of time because we believed, and we believe even today, that it was really a tremendous important factor to deliver a strong security posture to our customers. But before we started with the design of Azure Stack, we actually talked with a lot of you, and I see some familiar faces here. So in Azure Stack, in the product group, we, the program managers, we actually spend about 20 hours a week talking with customers from all over the world. And we have talked with hundreds and hundreds of you. And basically, we also ran surveys. And what you see here, these values are the result of a survey we ran with some of you, about 70 customers from all over the world, different geographies, different verticals. regulated and non-regulated environments. And what you told us was that 90% of you would like to verify the security posture and the track record before buying a solution, especially an integrated solution. And 75 of you said that would prefer buying a solution that already comes hardened versus having yourself to harden it yourself. Similarly, also you told us that you wanted a solution that comes already with security features pre-validated, pre-configured. And going on with what you told us is that 70% told us that integrating with existing security tools, third-party, first-party vendors, was very complex. 60% told us that the security was one of the main blockers to go to production. And finally, compliance paperwork was listed as #1 pain in the neck to go to production. And I see a lot of heads nodding here. So we took this feedback really to heart. And throughout the presentation, I'll show you how we actually address each one of these. So let's now look at really more to the substance, really what we have done in Azure Stack. So our approach was, instead of giving you a 200 pages manual and all the nice things you should go doing to secure Azure Stack, as some other competitors actually do, there are videos and manuals out there and say, hey, you should go do this, you should go do that, you should go figure out how to lock that down. We actually did it for you. So the entire Azure Stack infrastructure comes already hardened and comes already secure for you. So you don't have to spend those months to figure out how to do that. Yes, nor you have to go through hundreds of pages of manual.
One of the customers described this as saying, hey, you know, I wanted an aircraft carrier, and what I got was a bunch of iron ore and a wrench. Like.
So what I call the Azure Stack recipe basically is based on 3 main points. The one, we took the industry best practices. Then we took the Microsoft best practices. And finally, we also took the compliance. So we merged, basically, we took a look at the security posture, also keeping in mind the compliance requirements that you all have for all the standards out there. So we try also to include them into the design, to the architecture of Azure Stack. So in other words, the security of Azure Stack, it's built into the infrastructure. It's not a hat that we apply once we are done with building the system. It's not an afterthought. It's not like, okay, now we finished, let's try to figure out how to secure it, let's dump some software on top of it just to secure it. We actually built inside the infrastructure at every layer. And the security posture of Azure Stack is based on 2 principles: the assume breach and harden by default.
By the way, can I highlight something?
Please.
So I mentioned to you that I had been a security pessimist, and that throughout the company there was this kind of like awakening, and as we all came to the same conclusion at the same time, that the bad guys were getting better faster than we were getting faster. And so this really resulted in a whole bunch of security planning and Windows Server, but then also our trustworthy computing version 2 vision. And with this, we really had kind of a sea change. There were 2 things that came out of that. First, because of that awareness and the Snowden revelations, Microsoft had always been committed to security, but in reality, we were focused in on hardening our systems, and we were committed and investing to this level. But after this realization and the Snowden revelations, we were committed and investing at this level. So there was this increased investment in security and a change in our view of security. So yes, we would continue to invest in hardening, and we've done a fantastic job in upping our game in hardening the systems, but we also took a more mature approach. We said, no matter how hardened you get, there still can be breaches, and so we're going to assume that there are breaches. How do we deal with the situation? How do we be robust in the face of a breach, and how do we detect breaches, and how do we remediate from breaches? And we started to invest in those areas. And again, it's one of the reasons why Azure Stack has turned me into a security optimist, because of the things we've done here.
You kind of spoiled my slide now.
Oh, geez, did I? Oops.
So actually, what Jeffrey described is exactly the assumed breach. So we moved from only focusing on the detection and the prevention of the breach. which is the previous approach to security. Before, you will have a very beefy firewall on your corporate network, and that will try, the purpose of that one will be to keep the bad guys out. But once the bad guys went through that firewall, it was a fair game for them, and that basically they had the system, your infrastructure was conquered. So with the assumed breach, we sort of pivot the attention not only to try to prevent the breach, but also we assume the breach is already there. As also Michael Hayden told us, right? I mean, you basically rule number 2, you probably already penetrated. So basically what we did is we assumed the breach. So one, what can we do to figure out that we have been breached? Just to give you a number, industry average of detection is 200 days. So think of today, in your company, probably there is somebody that's been there for 6 months, and you have no idea.
And that was for the subset of people who found the person.
That's right.
Many of them are not found. By the way, oddly enough, so we just, like last week, we're having a conversation with someone fairly prominent in the industry. If I mention their name, half of you probably know them. And they said the following, they said, hey, and we're trying to collaborate on, if you see my tweets, if you follow me at all, something I constantly talk about is how we all have to up our security game, and that's not just a Microsoft thing. And so we're working with our industry partners to try and all of us up our security game. So we were having a conversation with them, and their position was, well, hey, if the bad guys get through the firewalls, it's game over. It's not worth even doing anything. And I was like, oh my heavens. You know, we were there like 7, 8 years ago, but I can't believe that prominent people are still there. We're not there. We're here.
And so basically, once we figure out, I mean, we put the effort in detecting the breach on one hand side. On the other hand side, we try to limit the blast radius of the breach. In other words, yeah, you compromise one component, that should not imply the entire infrastructure is compromised. So if you think back to the infrastructure picture we showed you earlier, if one of those boxes get compromised, that should not imply that the entire infrastructure becomes red. So it becomes compromised. And so that's really we took really this principle, the assumed breach principle at heart, and I'll show you now what we actually did to implement it. So, first of all, we started from the concept that the admin privileges is the first enemy. The admin have way too many privileges. And what that means is they become the most targeted role. Because obviously, since they have a lot of privileges, if you compromise an admin account, you have the keys to the kingdom. So you can roam around and enter any box, any server, any application, because you're an admin, right? And so basically we say, okay, enough with that. No more unrestricted admin. So the admin actually becomes constrained. The entire admin experience in Azure Stack is constrained. So there are no, for example, there are no domain admin credentials. If you buy Azure Stack, when it comes to your data center, you install it, you turn it on, and you will not have any domain admin credential. We won't have it either. Nobody will have it. Azure Stack runs without any human being having any domain admin credential. So there is nothing to steal, in other words. Yeah, they can phish, they can send you a phishing attack. Maybe they will steal your user credential, but that's a user credential. It's not a domain admin credential. And the way we made it happen is because basically in Azure Stack, there are only 3 entry points for the management. If you have attended any of the session in the previous days, you saw that we created a brand new management experience through the admin portal. That's a point-and-click experience, which only allows you to do the actions that the system is designed to do. So if somebody steals your credential, yes, they can connect to the portal, but they will only be able to perform those actions that the system is designed to do. They will not be able to connect into Hyper-V Manager, or Cluster Manager, Server Manager, or get inside data, because they don't have access. They only have those actions that we expose. And if you don't want to use the point and click because you like more using a programming language as, what's the name of the one?
PowerShell.
PowerShell.
Yes.
So if you want to use PowerShell to manage Azure Stack, you can. And you can basically hit the Azure Resource Manager layer, which is the API that exposes the entire capability of Azure Stack, and actually also in Azure. So if you don't want to point and click, you can go through ARM via PowerShell. But again, even ARM will only expose those commandlets that we designed the system to do. Because actually the portal it just makes a call on your behalf to the ARM layer. So the same actions you will see in the portal, you will see also on ARM via PowerShell. And finally, the third entry point you have is a lower entry point, and that's what we call the privilege endpoint. The privilege endpoint is a PowerShell GIA entry point. And are you guys familiar with GIA? Ever heard about GIA?
Anyone? Just
enough administration? Yeah? I assume you do, right?
Yes.
Okay. So GIA is basically, we whitelisted, it's a technology built in PowerShell that allows you to whitelist a set of commandlets and functions that you expose in a remote PowerShell endpoint. Therefore, if you connect that, you only have a very limited set of capabilities. And so what that does is basically, again, you have admin capabilities, but only for those capabilities that we designed the system to do. So if somebody steals your credential, they will only be able to do those actions. They will not be able to run around and execute whatever actions they want or get inside any box they want. Actually, the system is completely sealed.
Oh, and when they do that, when you connect in locally to the system, we have a full transcript, ubiquitous transcripting enabled. So you'll be able to see exactly what people typed and when they typed it and what the results were. So if there's any mischief, there's full traceability.
Absolutely. And you'll be able to export them and to store in some database or whatever system you want to archive. So if you have any retention policies for the action that were performed in the privilege endpoint, you will be able to store them and keep them as you want.
But can I point out here, the gestalt of what's going on is that you interact with Azure Stack as an integrated system, as an entity, not the components of that entity. So that's why I stress so hard. This is not, I'm never sharing my internals. The components you don't get access to. You deal with the integrated system, and I secure the integrated system and all the components underneath it.
So now I'm going to show you a little demo of the constraint administration. In particular, I'm going to show you the privilege endpoint. I won't show you the admin portal because I think you already saw it many, many times. If you haven't, just come downstairs to the booth, and we have 3 stations that we can show you the admin portal. So now let's move to 7. All right, so what you see here,
bigger?
Go ahead.
Can you make that bigger? Control plus?
Yes, Control plus plus.
More. That looks, how's that from the back seat? Can you read it? Yeah? It's all about you, so don't suffer in silence. Okay, good, thank you.
Oh, too fast. Okay, so right now I'm on my machine here. I'm going to connect to the privilege endpoint. So as you can see, I just enter PowerShell session. I pass the IP number and also my creds and the configuration name, as you can see, privilege endpoint. So it's not an open PowerShell endpoint. And if the network, there you go. So now I'm inside the privilege endpoint. And as I told you, you only be able to perform those actions the system is designed to do. So let's do a get command just to show you that I'm not lying. That's it. Those are the only actions that you have. You don't have the entire PowerShell library. And as you can see here, if you scroll with your eyes, you just see basically you have a bunch of get logs, because the privilege endpoint purpose mainly is for your data center integration. So when your system arrives in data center to perform, for example, ADFS federation, if you decide to use ADFS as an identity provider. The alternative will be Azure Active Directory. And the other purpose is support. So if the system, something bad happened, let's say some hardware failure, major hardware failure happens, and you have to go inside the system, you start from here. Here is where you get logs so that your customer support engineers can help you addressing your issue and fixing it.
So I was just pointing out that there are only 42 commands available to you. In regular PowerShell, you'd see many hundreds, thousands.
So again, as I said, those are the only actions you can do. So let's assume now that somebody stole your credential and they want to do something bad, like invoke Mimikatz. As you can see here.
Does everybody know what Mimikatz is? Mimikatz is a toolkit that you can get on a system, and it will harvest. It knows how to crack the SAM database and harvest any credential that's been used on that system. Scary stuff. I encourage you to download it and run it on your system, because it will truly frighten you. I heard about it. When I ran it on my system and I saw my password in clear text, it was like a punch in the gut, like, oh, now I get it. So easy. So now let's see if they can download Mimikatz and run it on Azure.
And by the way,
Stack.
Mimikatz is available for free. So going back to what we were saying, the script kiddies can get the tools. That's one on GitHub for free. You can download it. That's actually what I'm gonna do right now. As you can see, I'm just downloading from GitHub Mimikatz. So let's try to execute this. As you can see, it failed. And the reason it failed because it's not recognized an animal commandlet. It's not in the list of the allowed commandlets, therefore the system blocks it. And by the way, when it blocks it, you have also an audit event that's generated. So in terms of detection capability, if you see an audit event that something on the privilege endpoint failed to be executed, you already know there's somebody bad playing with it. Again, assume breach, detection, improving the detection. So let's go back to the presentation. Limiting the blast radius. So we lock down the infrastructure. And when I say limiting the blast radius, is because if one component is compromised, that should not imply that the entire infrastructure gets compromised. It should only imply that that component is compromised, and we are going to try to fight as hard as we can to give a hard time to the attacker so that the lateral movement are not easy, and if he or she succeeds, it's going to make a lot of noise. Therefore, we are going to be able to detect that he's inside. So we lock down the infrastructure. What that means is we apply code integrity. Code integrity is a feature Windows Server, built-in feature Windows Server 16, that basically allows you to decide what kind of software can run. In Azure Stack infrastructure, the only software that can run is software that either is designed by Microsoft or by our OEM partners. So if you try to run any other software, it won't let you do it. And again, an audit event is going to be generated, and you're going to be able to detect that somebody is trying to run unauthorized code. And actually, I want to also make a step back. What we are talking here today is really the security posture of the infrastructure. But when you think about Azure Stack, you have to keep in mind there are sort of two worlds that coexist. One is the infrastructure. Everything goes basically from the hardware to the portal. And on top of that, so that's the one we are talking about today, and the one we have hardened. And then on top of the infrastructure, that offers the cloud capabilities, like IaaS and PaaS capabilities, you have your applications, your tenant workloads. So those, it will be your responsibility to secure them. We are providing you a hardened platform, a hardened base on which you can build your secure applications. Unfortunately, our hands are a little bit more tight when it comes to your application because we don't know what you're going to deploy on top of it. So for that one, you're going to be responsible. But so for the sake of this conversation, what we're talking about today is related to the infrastructure. So everything that goes from the hardware all the way to the portal. So in the infrastructure, again, we apply code integrity. We use least privilege principle across the board. You saw an idea, for example, we are not going to give any domain admin credentials. And all those components communicates with accounts. They only allow them to do those actions that they are entitled to. So we really tie down the identities across the board. We also tie down the communication across the board. So all those components you saw in the architecture, they can only communicate with the other boxes they are entitled to. It's not that one component, every component can communicate with every other component. So we really selected who has to talk with who. If there is no required communication, that communication is blocked. And the way we enforce that block is through 3 different layers of ACLing. So we have a top-of-rack switches ACLs, we apply software-defined networking ACLs, and we also apply the firewall rules, both at the Hyper-V host and the virtual machine running on top of them. So we have 3 different layers of ACLing. So if an attacker wants to perform lateral movement, it will have to go through these layers of ACLs. Therefore, it will have to do a lot of noise.
Yeah, right. So this is defense in depth, or if anybody you ever watched Buffy and the Vampire Slayer, she'd say, kill them a lot. So this is defend a lot.
And also, there is no access infrastructure. The entire infrastructure is a black box. You cannot access the Hyper-V host. You cannot access the virtual machines running on top of them. You cannot access the components, the roles, like the compute resource provider, all of those components, software roles that run on top of them. And the reason is because it's sealed. You don't need to access that, therefore it's blocked. Again, the only actions that you can perform or that the system can perform in Azure Stack are only those that the system is designed for. Anything else is blocked. Detecting the breach. So we talked a lot about this already. And one thing we did is basically we enable all the auditing and all the security events in all the components, and we collect them and centrally store them in a storage account. The storage account exposes a REST interface that you can use to extract the logs, or you can use your third-party or first-party SIEM software security information event manager or other monitoring tool that you use for security to plug into that. It's a standard interface. It's a REST, HTTP REST. So through that, you will be able to extract the logs and store them for retention if you need to, or you can plug in your tools.
And the gestalt here, again, is that Azure Stack is a component in your environment, okay? So your existing management and security tools don't manage and secure the components of Azure Stack. They integrate and manage Azure Stack as a component, as a singular entity. So we expose a management entity for the entire thing and a security interface for the entire thing. They don't talk to the individual components.
And here you also can see, earlier I mentioned that we look at the security posture of Azure Stack from a compliance point of view. So this helps for your detection capability, but as well as for your compliance. Because a lot of the standards out there require you to collect and store and retain those logs. And instead of allowing you to install agents on every component in every Hyper-V host and every VM, we basically do that work for you and for your tool, your security tool, so that you don't have to worry about it. Also because since we have code integrity, you won't be able to run those. Assuming that you actually can reach and install those agents, you wouldn't be able to run them because they're not signed by Microsoft or our OEM partners.
Yeah, you want to know that dirty little secret of the industry? Okay. Turns out that the guys who write security agents, those security agents aren't very secure, or they're often not very secure. Often they are attack vectors in and of themselves, right? And they're often very privileged stuff. So that's a dirty little secret. And the answer is they're not getting on our systems.
So going back to the customer feedback, we all assume breach. We basically cross the fact that the solution comes with a set of additional features and targeted and validated and ready for you to use. Let's now go to the second pillar of our security posture, the hardening by default. As I already mentioned a few times, we are not going to give you a 300 pages manual and a lot of instruction on what to do on day one to start figuring out how to harden Azure Stack. We have done that for you. And the reason why we could do that is because in Azure Stack, we know and we control, and we decide the hardware, we decide the software, we decide how the software is installed, and we control how the software is configured. For example, from the Windows Server days, that's a completely different position. Windows Server has to be open, has to be flexible, because we don't know on which hardware is going to land, what kind of software application you're going to deploy on top of it, how you're going to manage it, who is going to manage it, and so on and so forth. Therefore, it has to be open, it has to be flexible. Azure Stack, it doesn't have to be flexible, and it's not open, because we control actually the whole pipeline. And what that does, it basically allowed us to create a hardened solution and bring a hardened solution to your data centers. So starting from the hardware, we have TPM 2.0 chips on every server inside Azure Stack.
By the way, how many people have servers with TPM 2.0? Yeah, oh really? A lot? Yeah, they've been hard to get. I've been working with the server community for so many years, and I'm telling them, you have to put TPM 2.0 in your servers. I'm gonna make it a requirement of Windows servers. Windows Server won't run on it until that. And then they say, well, is that true? I said, yes. And then at the end, it's like, well, it's gonna be a very strong recommendation. So, oh, well, it's not required. We're not putting it in. It's like, really? Really? And so, I don't know what the heck these guys had about TPM 2.0. But anyway, with Azure Stack, we said, no, it is a requirement, and now they did put them in there. So.
Well, we had to push a little bit, yes.
Yeah.
Then we also leverage Secure Boot and the UEFI to start the machines. Software install. We control the software, and we control how it's configured. So again, one of the common requirements for compliance is the operating system security baseline. So in Azure Stack, since we didn't want to have the conversation on who has the best baseline, we went for the hardest in the industry. We took a military level baseline, the DISA STIG, for Windows Server 16, and applied to Azure Stack. So any baseline you have is probably going to be either this one or a subset of this one. I mean, in your data center. So Azure Stack went directly for the hardest so that we could address even defense accounts, so customers that work in the defense industry.
And a STIG is a Security Technical Implementation Guideline. So basically, the military gets together, they look at all the control options on Windows Server, and they say, for the military configurations, this is off, this must be on, this must be at this level. And then that, you don't get to be on a military network if you're not implementing those STIGs.
And by the way, to apply something like that, it takes a lot of time, it takes a lot of validation. Because a lot of stuff stop working because maybe you tied up too much. So that requires a lot of validation. Again, validation that has been done for you. Since we didn't want to stay up at night, like happened a few months ago, with SMBv1 vulnerability that I guess all of you know, we decided to remove all these legacy protocols. And so SMBv1, it's gone. NTLM, gone. SSL 3.0 and below, gone. So we basically remove all those components that we already know they are source of vulnerabilities, and since we don't use them because they're bad, we remove them. And we also remove all the other components that they are not bad like these protocols, but we don't need them. So in terms of reducing the attack surface, we shrink it down, the Windows Server image and all the software running on top of it as much as we could. Right. Also because since we control the software, it's Windows, we control it, and we work really tight with our colleagues in Windows Server, we actually did very strong work together.
And the observation there is just because we don't know that it doesn't have a vulnerability doesn't mean that there isn't a vulnerability. So if we're not using it, we only include the things that we use. If we're not using it, we get rid of it so that there's no possibility of that component, which isn't necessary to the operation of the machine, interfering. You know, Wittgenstein, the great philosopher, once said, if you have a machine and you pull out a part and the machine continues to do what it did before, the thing you pulled out wasn't part of the machine. That's the model here. If this thing isn't part of the machine, it's not in the machine. We're pulling it out.
And then we leverage a lot of the security feature Windows Server 16, which really changed the game Windows in server operating system security. So we start from code integrity, already mentioned, only Microsoft and OEM code can run. We also use credential guards, so past the hash, past the ticket kind of attacks, you cannot perform them anymore in Azure Stack. Again, assume that somebody got in and they're trying to steal your credential, they wouldn't be able to do that. And obviously, every single host and every single virtual machine is protected by anti-malware Windows Defender. In terms of configurations, we also apply everything and turn on everything we could, starting from data rest encryption. So all the compliance out there, they all require data rest encryption. So instead of leaving that to you as a parameter, we just turn it on, and so we are done with it. So data rest encryption via BitLocker enable an entire storage system of Azure Stack. That includes both the infrastructure side and the tenant space. So if your customers or your departments or your application write data right on the storage, all that data is encrypted at rest. So that in case somebody goes in and steals a disk, that disk is going to be encrypted. Network encryption across the board. All the communication, you remember all those components I showed you in the architecture? All of them communicate using TLS 1.2. And the reason why we could do that is because we have a PKI, a certificate authority inside every single stamp, every single deployment. So all the certificate management, we can do that for you. And actually, we also use those certificates for authentication between the components that talk and authenticate with each other through Kerberos. And we also provide you the scripts to automate. Actually, we already automated. We give you the script to do that for the certificate rotation. Our Northern Star is actually going completely autonomous, meaning that the system will rotate the certificate when we decide in a very, very fast pace. That's something we are going to, but right now you can already do that by hand by running the script. All the accounts, all the components communicate using group managed service accounts. The awesome thing about GMSAs is that they can rotate the password autonomously. So we rotate those passwords once a day. Every 24 hours, those passwords get rotated. So that's the highest frequency you can possibly set the GMSA account. So it means that even if you steal one credential, one service account credential, that's going to last to the attacker for 24 hours. And also we give you a script to rotate the storage account keys. So even those, your storage keys, also those can get rotated. And so when we come back again to the feedback that you gave us and the request that you had for us, you told us you want a hardened system. There you go. Everything we could possibly harden in Azure Stack, we did it. And also, you told us that security was one of the main obstacles, at least from our infrastructure point of view. We think that we gave you a very good starting point to get in production. Then obviously you will have to deploy your application and figure out how to secure your application, but at least you don't have to waste a lot of months in figuring out how to secure the infrastructure. And so now, let's go back to the privilege endpoint and have some fun with that. Ooh. This Windows, hello, it works magic. I love it. So the privilege endpoint, as I said, is basically designed for two main scenarios. One is the data center integration, and the second is support. So now, what the support does, basically, via two-factor authentication, allows you to elevate your privileges working with a customer support engineer. So you cannot do that by yourself, nor we can do ourselves. We have to be together. So it's a two-factor auth with two people, two different organizations, two different systems. And I'll show you.
It's like launching a nuke. You need two keys. Right?
That's right. And so once you go through the two-factor authentication process and you succeed, you basically have an elevation of privileges, which allows you to reach inside the infrastructure. Until that point, the infrastructure is completely sealed. So we're going to use that two-factor authentication to simulate somebody actually got into the infrastructure, somehow compromised one of those components, and has domain admin credentials. So let's see if he or she can do any damage.
So I want to kind of highlight again what he's saying here is we have a support path whereby you can gain privileged access to one of the systems. He's going to use that to emulate a bad actor having found a vulnerability that we didn't know and them having gained privileged access to a machine. If that bad thing happens, this was what happens.
Okay, so the two-factor auth, basically, you have to, oh, where am I? I think I made. So you get the token to unlock the system by executing the get support session.
Oh, and the other, you're already in the GIA endpoint.
Yeah, hold on.
Can you run it in the GIA endpoint?
Mm-hmm.
No?
Ah, session token, that's why. See, I was missing the word token. There you go. So that's a token.
Oh, they've seen it.
Well, this is actually generated on the fly.
Oh.
It has, I think, a 256 RSA encryption algorithm, so good luck. So now I'm going to do, so that token, you're going to give it to your customer support engineer. Because with that token, you can do anything. It's not going to let you get in anywhere. It's only a token that you have to pass to your customer support engineer after you open a ticket, a support ticket. So what I'm showing you, what you're seeing here is something you will never see in real life because this is actually the portal where the customer support engineer has to log in to basically validate your token and generate an authorization token. Again, I'm doing this only to simulate the fact that somebody was able to get inside the infrastructure. So I pass the token, authenticate. I think I probably have to, yeah, hold on. But I had to reboot the machine.
What?
Not before. So
Okay.
yes,
But he was mentioning we had 10 minutes.
all right. Okay.
Secure. Look at that. That's awesome.
There you go. Okay. Now we are in. Let's pass the token. That's the response token. So what we are going to do now, we are going to do unlock support session. And we pass the token. So again, now it's you that you receive the token from the customer support engineer. And at this point, the session is unlocked, so you haven't elevated your privileges. Just to give you an idea, let's do a get command, which I mistyped it.
Remind me to teach you how to use tab completion.
So now you see, you have the entire PowerShell library. And now, again, as you saw, I'm not using any domain admin credential. You're still using your user credential. But in the back end, you're actually running as a domain admin account with full reachability inside the infrastructure. So again, this is for support scenario.
Yep. And again, we're emulating a bad guy having exploited a system and somehow they get this.
So what
It'll never happen, but if it does.
So what I'm going to do now, I'm going to download the ICAR. The ICAR is basically a test payload that usually you see to use to measure your defense. So we're going to download that one.
Remember, previously you couldn't use invoke command because it was the GIA endpoint. But here, because he can do anything, he's got it unlocked, he can call that.
Yep. So I think I downloaded it in downloads. So let's do it there. Okay, so let's try to touch that software.
Tab.
And so as you can see, the antivirus immediately blocked it and deleted it. So again, defense in tab. Yeah, you were able to breach into the system, but it wasn't, you wouldn't be able to do anything. So the bad guy wasn't able to run any bad code.
Right, so it was there, but in the background, the anti-malware system found it, opened it up, analyzed it, decided it was malware, and quarantined it. So then it went away.
So now, okay, let's assume the bad code is not so easy to execute. Let's assume now we want to execute something that is apparently good, like Chrome. So I already downloaded, as you can see here, I downloaded Chrome. That's just from the Google website. So Chrome is actually obviously a good piece of software. So let's try to execute that one. That's a Chrome installer. Blocked. Why? Because it's not signed by Microsoft or by our OEM partners. So what it does, not only blocks it, but also created an event into your event logger, and so that if you see the event, in this case is the 3077, that basically if you see the 3077 into your event viewer or into your SIEM system, you already know that somebody is doing something bad. And in case of the Windows Defender that caught the other piece of software, that was an event 1176. So those are regular standard event in Windows. But again, now you know that as soon as you see something like that, there is something really bad happening. All right, let's go back. Any question?
Good, we don't have time for questions.
All right, actually here, I have to be here. So SIEM integration. Remember one of the things you told us was that integrating with security tools is a painful process. So we're actually working with several security tool vendors to make the integration easy and straightforward.
And explain what SIEM is.
So SIEM stands for Security Information Event Manager. It's a tool that you collect audit logs, collect security events, and looks for patterns, and it has some heuristic, some rules, basically look at those logs and look at those patterns, and use those to detect whether something bad is happening. And usually throws warning, throws alerts, and so on and so forth. So, and by the way, most of the compliance standards require you to have one of these. So in this case, I'm going to show you actually a video with a demo of one of the partners that we work with, Event Tracker, and they did a fantastic job to actually integrate with the REST interface so they can pull the logs out and integrate in their system.
We're going to pick it up.
Hi, I'm Anant with Event Tracker. The topic is security event logging from the Azure Stack. Let's see what happens in Event Tracker when such an event is generated.
They get written to blob storage and picked up and processed by Event Tracker. Here's the Defender event 1116. As you can see, Windows has blocked this code. Now, because Event Tracker is a single pane of glass, there are other events, including code integrity, something from the Cisco ASA, and then also something from the Dell chassis suggesting that the door is open. Event Tracker is available both as a product or as a service backed by a 24/7 SOC. So some of the vendors are actually very happy to announce that already work with Azure Stack, and the number is growing, and is Event Tracker. Qualys, it's a vulnerability scanner, so you can point it to your infrastructure, to your workloads, and you can download it from the Azure Stack Marketplace, and you can deploy as a virtual appliance inside Azure Stack. Enter Micro for the protection of your workloads. Going back to the feedback, the integration with security tools addressed. So finally, last slide, actually last two slides, we wanted to be transparent with also the compliance. We understand that you need to understand, your security team needs to understand how the security in Azure Stack is done, whether we have done our homework. The short answer is yes, we have done it, but it's not like trust me kind of story. If you want to see the threat models of Azure Stack, the components, the infrastructure, you'll be able to access them. We also hire not one, but two different penetration testing companies to hammer Azure Stack infrastructure. If you want to see the reports of those, you'll be able to receive them. Obviously, those are very sensitive materials, so they are under specific restrict NDA. But in case your company has the needs to see those documents, we are able and we are happy to share them. Again, we address also the track record, and so you can trust the solution. Finally, compliance. We understand that compliance is a major story to go in production, and also one of the major most painful story. So what we did in Azure Stack, we actually hired a third-party assessor organization, the TPAO you see here, to do a formal assessment on how Azure Stack meets the compliance requirements of some of the major standards out there. And what we are going to do, we are going to give you the documentation that describes how Azure Stack meets the controls, the applicable controls to the infrastructure. I want to also be very clear here. We are not certifying Azure Stack because we cannot. Azure, we can certify. Azure Stack, we cannot. And the difference is because in Azure, Microsoft owns and operates Azure Stack. Sorry, Azure. In Azure Stack, you own it, you operate it. Therefore, we cannot certify because most of these standards have controls that apply to, fall into 3 buckets: technology, people, and process. Since you own and operate Azure Stack, people and process is your responsibility. That's why we cannot certify Azure Stack. But yet, we are providing you the documentation that describes how Azure Stack meets the controls applicable to the technology side at the infrastructure level. Because again, for the application level, I don't know what application you're going to deploy on top of it, therefore I cannot respond and answer those controls. In terms of standards, we are starting with PCI DSS, and we are going to have the documentation in the next couple of months. And also we are filling up the Cloud Security Alliance Cloud Control Metrics. That's a one-to-many, I think it's 30 different standards out there. That includes HIPAA, FedRAMP Moderate, and ISO 27001. So again, if you are following if you have any of these, you'll have the documentation on how the Azure Stack infrastructure meets the applicable requirements. Finally, and this is different, because actually for common criteria, we are going after the certification, but it will take several months to get there because the process is just long. And the reason why we can go for common criteria, because common criteria is an attestation of the security claims. It's not like a bunch of controls and we have to explain how we meet them. It's actually an attestation of the security claims that a vendor does. So common criteria, we're going after that, but it's something it will happen in next calendar year. So with that, we also addressed the last requirement, which was the compliance paperwork. So we want to help you getting up to speed, also with the compliance story as fast as you can.
Emily, can I just say that this is one of the things I'm just so wildly enthusiastic about this area, because it really kind of highlights 2 things about the new Microsoft, right? So first is, that, again, we've long been dedicated to security, and what you see is a new modern approach to security that is really, in my belief, is just going to be transformational security as best highlighted here. You know, honestly, I've got friends in the security business, and they look at what they're doing, and they're just so jealous, like, oh my gosh, you guys are doing it right. You know, we try and tell everybody, but for whatever reason, you guys are finally doing it right, so they're jealous. But then the second is, as Filippo highlighted, this is all customer driven. We start from listening to our customers, and that prioritizes our work queue. And what we heard was you guys needed next generation transformational security, security that you can trust on and rely on and didn't have to spend all your time and energy configuring, and that's what we're delivering.
Thank you. So, recapping, Azure Stack security is based on 2 design principles: assume breach or defense in depth, and harden by default. So the infrastructure of Azure Stack comes already hardened for you, so you can focus your attention on building your application and securing your application, and the rest, it's solid platform for you to build on top.
And with that, we actually don't have any time for Q&A, and so I don't repeat the mistake I had here and miss my talk. I'm going to be zooming across the hall. If anyone wants to come to my PowerShell Unplugged talk, it's going to be in E1, and I'll have time to talk to anybody after that. But hopefully this was a good use of your time. I think you're going to love what we've done in security in Azure Stack, and if you're building your own systems, I encourage you to try and emulate the things that we've done here. Thank you for your time.
Thank you.